This is video number 2 for sections 4.4 and 4.5, writing exponential functions, the difficult case. So what we're going to do now is consider the situation where you're trying to write the equation of an exponential function, but you don't know the values of a or b. Neither of them is given to you. Take a look at our example problem. Find the equation of the exponential function that goes through these 2 points. I could, if I wanted to, write it out as a table or in a table. And you can see there I don't have an x value of 0, which means I don't know the y-intercept, the a, and I don't have my x's going up by 1, which means I have no easy way of figuring out the b. So I'm going to have to figure out both a and b. Well, how to start? I know that the final answer is going to look like y equals a times b to the x. That's what all exponential functions look like. All I have right now is a couple of points, and so what I'm going to do is I'm going to begin by plugging in each point. The 4 comma 3.1, I'll plug that in, 3.1 for y, and 4 for the x. Remember, you're filling in an x and a y. You don't know the a or the b. I can do that with the second equation, 11.3 equals a times b to the 6. Well, what I have now is a system of equations. I have 2 equations with 2 unknowns. My 2 unknowns are a and b. So I can think of this kind of like we did back in chapter 3. Well, one of our methods back in chapter 3 was the method of elimination. You remember that's the one where we would add the equations together in the hopes that one of our variables would drop out. That's not going to work for us here, but it turns out that what works is for us to divide the equations. You can see the list of steps we're following over here on the side. Dividing the 2 equations will serve to eliminate one of our unknowns. Now there is a tip written right below it. When you do your division, when you write your 2 equations, you need to make sure that the one with the higher power is written on top. In our problem, the highest power we have in this problem is a 6. Let me rewrite these 2 equations with the higher powered equation on top. Now that I have them written, the step is to divide the 2 equations. Literally, take the left side, do that division problem. Take the right side, carry out that division problem. On the left, that is not a nice division problem, and I don't want to do any early rounding, so the best I can do is just leave it alone. That's just 11.3 over 3.1. The right side of the equations, this is the best part. These are all just factors over here, which means anything that's in common I can certainly divide out. I notice that the a's are common factors, so I can simply divide those out. They're gone. Well, look what I have left. B to the 6th over B to the 4th. That should look familiar to you. That's one of our rules of exponents. How do you divide 2 items with the same base? Well, the base ends up on the top. In other words, there is no fraction anymore. And you simply subtract the top exponent minus the bottom exponent. 6 minus 4 is 2. This is now the resulting equation from dividing the previous 2. And it's great. The a is gone. I now have a simple equation involving b that I can solve. It is once again a power equation. In fact, the only thing to do in solving it is to get that b by itself by removing the power. How do I do that? I take each side to the reciprocal power, in this case the 1/2 power. And there's my value of b. b is 11.3 over 3.1 raised to the 1/2 power. Now that's the exact answer. What they're generally going to want from you, though, is a decimal approximation. You should look in the instructions of the problem to see what they want. I didn't type anything here, but many of the problems say something like round your final values to 2 decimal places. Let's go ahead and do that. So grab your calculator, type that in. We'll round off our b value to 2 decimal places. That comes out to be a b value of approximately 1.91. Remember, depending on your calculator, you may need a couple of sets of parentheses here. You may need the one around this fraction, and you may need another one around the 1/2. Make sure you learn how your calculator works. All right, well, now that we have our b, again, think back to the method of elimination back in Chapter 3. Once you figure out one of your unknowns, what do? Well, you take that value, you go back up to one of your original equations, you fill it in, and that's what allows you to solve for the other unknown. So that's what I need to do now. I need to take that 1.91 and fill it into one of these equations in place of b. That gives us 3.1 equals a times 1.91 to the 4th. I'm just trying to solve for a. I can do that in one last algebra step here. Now perhaps you're looking at this part thinking, oh, we should go to the calculator and work this out. I don't want to do that. I think that's going to be a pretty long, messy decimal, and I don't want to do any rounding in the middle of the problem. I'm only to round final values. So just keep it this way. How would you get a by itself? Well, currently it's being multiplied by this big mess of a number. All you got to do is divide both sides by that number, by 1.91 to the 4th. Now the a is by itself. Here would be my exact value of a. But of course what we're going to be interested in is the decimal approximation. You can just type that into your calculator just how it looks. And so we get a is approximately 0.23, again assuming we're rounding off to 2 decimal places. If you're not matching that, you need to figure out how your own calculator works. For the TIs, the way that you would type in this expression goes like this. 3.1, the division symbol, 1.9, the exponent symbol, and 4. All that's left is to write our answer. We now have a and b. I just need to fill them in. Looks like my final exponential equation is y equals 0.23 times 1.91 to the x. This method will work every single time you're given 2 points and you can't just tell the values of a or b. And one final comment back to the issue of putting the equation with the higher power on top. The reason that that is important is so that when you use that rule of exponents and you subtract, you end up with a positive power here. If you were to put the lower power on the top, you'd end up with a negative exponent here. That's not impossible to work with, it's just more difficult. So we want to avoid that and always put the higher power on top when dividing.